What is the theory of relativity? Relativity is primarily a theory about the motion of moving bodies. It was formulated by the German physicist Albert Einstein in the beginning of the present century. The theory is in two parts: the special enlv bodies moving at a constant velocity relative to each other, and the general theory, 1916, deals with the problem of gravitation. Time. Theory of relativity is based on two postulates. I, the speed of light in vacuum, is constant and does not depend on the source or observer, and two, that laws of physics remain unchanged in all inertial frames, matter at rest or in uniform motion. In the early 19th century, people believed that light traveled through an imaginary stationary medium called the ether. 1. T. Was believed that ether filled all space and all movement could be measured absolutely with respect to it. It was also thought that the speed of light, relative to a moving observer, could be calculated in the same way as the relative speeds of any two moving objects. For example, just imagine two cars in the same direction, one going at a speed of I km/h and the other at 80 km/h. Passengers in the slower car would observe that the faster car is traveling at 30 km/h. So we can say that the relative speed of faster car with respect to slower car is only 30 km/h. Two American scientists, Michelson and Morley, experimentally tried to measure the speed of Earth through ether in 1887. They could not detect it. The result obtained by them was considered inexplicable and did not conform to the existing scientific theory in this regard. Later, the explanation of the negative results was offered by Albert Einstein. According to him, nothing like ether exists, and concept of absolute motion is meaningless. Or also said that the speed of light always remains the same, no matter how fast is the observer moving. The speed of light is absolute, and no material body can travel faster than light. On the basis of his conclusions, Einstein formulated special theory of relativity and showed the physical quantities like mass, length and time are also not absolute, change as the bodies move. If a body moves with large velocities, its mass increases, and these changes are not noticeable when the bodies move with ordinary speeds. They become shorter. Become significant only when they move at very fast speed, approaching the speed of light. Cars on the freeway do become heavier and shorter as they go faster, but the effect is very small. On the other hand, an electron traveling at 99% of the speed of light becomes 7 times heavier than its mass when it is at rest g. According to Einstein's theory, nobody can actually attain the speed of light. If it did, it would be infinitely heavy and have zero length. The increase in mass and decrease in length of a body as its speed increases led Einstein to conclude that mass, m, and energy, E, are different aspects of the same thing but are related to each other. This led him to the famous mass-energy equation, E equals mc2, where c the velocity of light. Nuclear energy is a direct consequence of this equation. The second part of Einstein's theory is called General Theory of Relativity and was published in 1915. The special theory applies only to bodies moving with constant speeds. General theory deals with the accelerated motion of the bodies. It deals mainly with the way the force of gravity works. He suggested that the force of gravity is a property of space-arid time. He showed that space becomes curved by the presence of mass. The motion of the stars and the planets are controlled by this curvature of space. Light rays, too, are bent by the curvature of space around a body that has mass. Einstein's theory of relativity is one of the greatest achievements of the human mind. Einstein, like Newton, was one of the most creative scientists of all times.